Hello friends, welcome after a long break. Today's topic is work and energy. Now to understand energy, you should know that work is again a term which you should know. Now what is work? Work is done when some force is applied to a body and the body moves in that direction. So what will we get for work as? Work is force into the distance the body moved. So work is F into S. What are the units? Work unit is joule, force is Newton, distance is meter. Now understand that if work is done, our energy decreases. But because of that work, the energy inside the other body increases. We have to understand the concept of gravitational force over here. So we should know that state of a body changes when you work on it. Now we have the next point, that is energy. What is energy? We all know capacity to do work. We eat food to get energy. Now always keep in mind two things, that gravitation is always acting on the body and the body possesses some energy during rest as well as motion. Also another concept to be always kept in mind is law of conservation of energy. Energy is always conserved. Next point is the units. Work and energy have the same unit, that is joule. But the other unit for energy is calorie. Especially for heat we use calorie. So what is the relationship between them? We know that 1 calorie is 4.2 joule. Exactly it is 4.18. Got it? So joule is Newton into meter. CGS units of force we know as dyne and energy we know as erg. Then we go to the types of energy. You all know there are almost 8 types of energy. What are they? Just list them down. Mechanical, heat, light, chemical, sound, magnetic, electrical and atomic or nuclear energy. Now we'll go only to this part today, that is mechanical energy. We have separate lessons as heat, light, chemical, sound and so on, but today we are focusing on mechanical energy. So what is mechanical energy? It is the energy possessed in a body due to the state of either rest or motion. Now rest is called as potential energy. For example, we have a wound up watch, we have spring which is compressed, we have a stretched rubber band. In motion, we have kinetic energy. What are the examples? Falling of hammer, a thrown stone, a flowing water, a bullet fired. All are examples of kinetic energy. Now, what are the factors affecting these two energies? You understood that potential energy is energy during rest. So, what will be the factors which will affect it? Mass and height. Mass and height. Remember this. So we get the formula as mgh. G is gravitation or acceleration due to gravity. Kinetic energy is mass and velocity. What is the formula? Kinetic energy is equal to half mv square. That comes out to mv square upon 2. And finally, we have the energy conservation law. What does it say? That energy is conserved. So potential energy is finally equal to kinetic energy if there is no friction. What are the examples of conservation of energy if you understand? Roller coaster and falling off a ball. This is all for today. We understood mechanical energy today in detail and we understood that energy can be transformed and conserved.